everyone. So I'm going to continue on with question or year 2019 Physics C set 1 questions. This time I'm going to move on over to question 2. Now, I want to remind you that, as I mentioned before, there are 3 questions in this test, and the second question is pretty much always a conservation question, conservation energy or conservation momentum. So you want to keep that in mind. And in fact, a lot of times they're probably going to try and find a way to combine both of them, conservation momentum and energy together. Like I said, it's a conservation question. So in this first one, it's a very typical question that they ask. It's essentially a ballistics pendulum type setup. This is very easy way for them to combine energy conservation and momentum conservation. So they tell us that the block is originally up and it's going to swing down to block 2. Now, before I actually keep going, I forgot to mention, make sure that you try this out yourself. The link to the question will be in the description below. So the block is at a height so that the string is completely horizontal, and it's going to hit block 2 basically when the string becomes completely vertical. And they want to know the speed of the block just before it makes contact with block 2. So again, you want to try to keep your blinders on essentially and only focus on the question at hand. It's going to slam into this block. This block's going to fly. The pendulum's going to swing up. Doesn't matter. I don't care. I just want to know what is the speed right before it hits block 2. So the conservation I'm going to do is I'm going to do the total energy is being conserved. So at the very top of the swing, this object only has gravitational potential energy. And at the very bottom of the swing, it has only kinetic energy. So I'm going to set these two equal to each other. M1 GH equals M1 B squared over 2. The masses drop out like they almost always do. This is probably the hardest part about this question is realizing that the height is going to be the length of the string L. Since it goes from being horizontal vertical, that's a height of L. Solve for V. So this ends up becoming root 2GL. All right. For part B, they want us to label the forces acting on block 1 just before it makes contact with this. And we have to have all the arrows starting here, and we need to make sure that the force with the greater magnitude is represented by a longer vector. This is the important aspect. Going back to A, this was a 1-point question. So really, this was the only thing that you had to do. And honestly, this is something that AP1 students, even some region students, should be able to do. Going back to this, so this is just a standard FBD. The forces are pretty easy to tell. It's going to be gravity force going down and a tension force going up. Now the trick part is this last sentence of making sure that they are drawn in proportion. What this means is I have to recognize which one of these is bigger. This is where you have to kind of go back to the circular motion setup. This object is in a pendulum. It's moving in a circular arc. The centripetal acceleration, therefore, is pointed towards the center of the circle, pointed upwards. So that means that this tension force has to be bigger. So when I draw my arrow, I want my tension force to go, let's say, 3 boxes up. The gravitational force, on the other hand, I don't want it to go as high up. I only want it to go 2 boxes down. It doesn't really matter what you label it as long as they kind of recognize what you're trying to say. But you end up getting 2 points for this. 1 point for just stating that these are the forces, and 1 point for recognizing which one is bigger. So these are the 2 points there. Part C, it says derive an expression for the tension force, blah, 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 at this point, essentially. The key thing here, they do say that don't edit this. A lot of you are going to want to do FBDs. You might want to draw an acceleration. That's fine. Just don't touch this diagram that you have. So for part C, I don't like that. I guess I'll do red still. For part C, what we're going to do is F net equals ma. My forces that are acting on me are tension and the force of gravity. And I should probably clean this up. That looks like a G, M-A. The A in this case, because it's moving in a circular pattern, is going to be a centripetal acceleration, which is v squared over r. So tension is going to be equal to mv squared over r plus Fg, which is just equal to mg. These are all mass 1 for the most part. From here, I just need to plug in the numbers. So it's going to be m1. Now I actually know what the speed is. They told me here. I figured it out in part A. So that's going to be square root of 2gl time being squared. So that just gets rid of the square root. So this is going to simplify to just be 2gl over the r in this case. The distance to the center is going to be L. And this is going to be plus mg. L's drop out. So I end up with 2mg plus mg. So I end up getting that this is going to be equal to 3mg. Makes sense since we know that ft has to be bigger than fg, that I should be getting something that is some multiple bigger than mg. Now, I'm actually not done yet because this m, I dropped the subscript, but this is m1. If I look back in this question, it tells me that M1 is 3 capital M, essentially. So I need to actually plug that in. So I'll write it here first. So it's 3M1G. That's 3 times 3 capital MG. So this actually will become 9mg. And that's pretty much it. Now, one thing I want to actually go back to here, if you look at this question, it basically says this response. It basically says that ft is going to be 3 times bigger than fg. You do not need your diagram to represent that. The diagram does not need to be in proportion. It just needs to show that one of them, that you recognize that one of those forces is bigger, and you know which one it is. All right. So now let's go down to part D. So part D, it says calculate the time. So they give us a number for what the pendulum length is. They want the time it takes for block 2 to leave the table and hit the ground. So if we look back up to here, let's grab black this time. This is in this scenario, this is a projectile. So what they're really asking is how long does it take for this object to fall 2L distance? Because remember, in a horizontal projectile, the time it takes for it to land on the ground is the same as if it was just dropped to the ground. So for part D, I'm going to do, I'll use the annoying x equation. Pretty much this entire first part drops out because, again, I'm pretending that it's just being dropped. I'm going to completely ignore the fact that it's actually being launched. The length is 2L, so this is going to end up being 1.5 meters. And that this acceleration is 10. Probably should have just made that 5. So moving things around, this will end up being 1.5 times 2 divided by 10 will be 0.3. Take the square root of both sides, and we end up getting 0.55 seconds as my time. This was a 2-point question. So you got 1 point for basically doing all this part. This was 1 point, and this was the other point. I forgot to mention up here, this was also a 2-point question. Similar thing, 1 point for this, 1 point for basically all this. All right. Part E, they want us to figure out the speed of the block as it leaves the table. So I'm actually going to only move up a little bit and then go over to the side. So we know that the horizontal distance is going to be 4L. So what I'm going to do is, this is E, I guess. I'm going to use the same equation. This time, though, I'm going to use only the X values. Because I'm using the X side, this drops out and this drops out. This X position ends up being 4 times the 75 centimeters. So it's going to be 3 equals, I'm looking for the initial velocity, and I know the time is 0.55 seconds. So this means that my answer should be about 5.5 meters per second. A little serendipitous, but same thing. All right. This was another 2-point question, 1 point, 1 point. So same thing as last time. Going down to over here, they want the speed of the block right before, or sorry, speed of the block after it collides with block 2. Okay, so this is where it gets a little bit fun. We already know what the speed is before. We know that block 1 is traveling at a speed of 2 times 10 times 0.75, which if I plug that into the calculator, that ends up being 3.87 for block 1. I know what block 2's final speed is. It's 5.5 meters per second. So what I'm going to do is I'm going to use conservation momentum to figure out what block 1's final speed is. So I know in the beginning, P before equals P after. I know that in the beginning, the initial momentum is coming just from block 1. So this ends up having a momentum of 3m times this 3.87 velocity. Block 2 has no momentum, it's at rest. At the end, we have block 1 has some unknown final velocity, and block 2 will end up having momentum of m times 5.5. All right. So with this, I can try to clean up. Well, each of these terms has an m, so I can actually drop out and ignore the m's from now on. So 3 times 3.87 is 11.61. 3v1 plus 5.5. So I just basically solve this the rest of the way. And I'll end up getting that v1 is about 2.04 meters per second. All right. So this was a 3-point question because most conservation momentum questions will, especially something like this, will end up being 3 points. You get 1 point for essentially stating conservation momentum. You get 1 point for plugging the numbers in properly. So that was another point. And then you got your third point for, well, I shouldn't say plugging the numbers in, setting it up. Setting up what the mass is, what mass goes with what speed. And then you get your third point for this whole part of plugging the numbers in that you got before to get your final answer. All right. And now for the last question, part G. Find the angle that it makes to the vertical. So there's a few different ways of doing this, but the I think the easiest one we're going to do is going to do conservation of energy. So once again, at the bottom, we know that it has a new kinetic energy. So this is my new kinetic energy at the bottom, going to be equal to my new potential energy at the top. Uh, Once again, this is just going to simplify to be this one GH as my new height. Plugging the numbers in, 1/2 my new velocity is 2.04, 10GH. So plugging the numbers in, I end up getting that the height will end up being 0.21 meters. This is where it can get a little tricky. So now what I have to do a little bit of geometry. So I know that when it lifts up to this angle, right, this entire length was equal to 0.75 meters. And also when it reaches this height, this part is also going to be 0.75 meters. So this was where it is at the when the block was at the bottom, and this is the block, swinging up to the top. Now I know that it went a height of 0.21 meters. So what I can do is I can use math and say this segment line and this segment line have to add up to 0.75. So 0.75 minus 0.21 is 0.54. I'm looking for this angle. So what I can do is do adjacent over hypotenuse. I'm only looking at this triangle now. So this is the thought I could do something else. All right, so this is the triangle that I want. I'm going to do cosine of the angle is equal to adjacent over hypotenuse. That's going to be equal to 0.72. And then take the inverse cosine of both sides. So theta is inverse cosine or arc cosine of 0.72. This will end up getting me cosine that theta max is 43.9 degrees. All right. And that's this one. Like I said, this one was a little bit tricky, but honestly, if you've done one ballistic pendulum question, it always ends up being like this. So you would have known this pattern of realizing that you had to add up these lengths to get the total length, and that this length and the new hypotenuse are the same. So yeah, just be aware that if you've ever done a ballistic pendulum, it's always the same method, which is why I made the comment originally. This is a 3-point question. You got 1 point for the conservation of momentum. You got 1 point for plugging the numbers in. So plugging the numbers in to get the new height. And you basically got 1 point for this. And that's it. If you have any questions, feel free to let me know. I'll be going over the next question shortly. All right. Have a great day.